In this video, I'm going to give an introduction on how to graph a linear demand curve. So to even talk about a linear demand curve, we need to know what demand is. Demand is going to be a function that relates quantity and price. Namely, it says given a price, what quantity do I demand? So that's what we're going to start off with. So as we can see, sort of given this sort of intuitive idea, demand is quantity as a function of price. And so the way I've written this here is quantity is a Q of P is a function of P, and that is what we call the demand function. So I'm going to put in a box here. This is the demand function, and that's what we're going to be interested in graphing in this video. That demand is a relationship between price and quantity. So if we want to describe a demand curve, we have some axes here, but sort of in addition to just having these axes, we need to label these axes to know anything that we're talking about here. And the standard way to label these axes is to put price on the vertical axis and to put quantity on the horizontal axis. And once we have price and quantity on the vertical and horizontal axes, we can start to think about graphing a demand curve. So let's take an example. So let's take a very concrete example, a linear demand curve. Q equals, and it's going to be some function of P, but I'm going to make it a nice simple function. It's going to be 10 minus 2P. That you've got a slope and you've got an intercept. But there is a problem here. Back in your high school math class, this was y equals mx plus b. If you were going to have it in slope-intercept form, that's how you were to think about it. So that was y equals mx plus b. Now that's going to be a problem if you sort of look at this, because usually in a math class, x is here on the horizontal axis and y is on the vertical axis. But as you can see, the way we've drawn this, and this is standard in economics, I want to point this out. This is the first thing you should see when you're thinking about graphing a demand curve. First thing you see is that we have this in x equals mx or my plus b. P is playing the role of y, and Q is playing the role of x. So we don't have this in y equals mx plus b, and what we like about y equals mx plus b is that's the slope and intercept form. So we could sort of plot the intercept, the y-intercept, and then take a slope, that's rise over run. We can kind of visualize that and just graph. But this isn't in a graphical form at this point. It's in the conceptual form. This is a way I like to think about demand conceptually. It's what it is. It's quantity that is desired at a given price. But when we go to graph things, it's reversed. And this is just standard in economics. It's not because the economics profession wants to confuse you. Let's see what we can do with this particular demand function. One thing we can do is we can solve this demand function for price instead of for quantity. So price in terms of quantity instead of quantity in terms of price. We can add to both sides 2p, and the 2p that I add to the right hand side cancels the 2p that was over there. So we end up with this equation reduces to q plus 2p equals 10. I'm doing this really slowly here. And then you can subtract q from both sides. And it's going to cancel the q on the left-hand side. It's going to bring it over to the right-hand side. And so, as you can see, what we'll end up with is 2p equals 10 minus q. And finally, let's divide through by the slope coefficient here on this price. What we'll end up with is 10 divided by 2, well, that's just 5. No need to write that out. And then 1/2 q, because we're dividing every term by 0.5, or divide every term by 2. So then we get this nice expression here, and this nice expression is what we call the inverse demand curve. So once we solve for price as a function of quantity, we call that the inverse demand curve. I like to call it the graphical demand curve. It's not how we conceptually think of a demand curve, but it is how we think of a demand curve when we want to go graph it. And the reason is that this is slope-intercept form. Here's our intercept, and here's our slope. So if you like the y equals mx plus b, p is like y, q is like x, and we've got this in a little bit different order than y equals mx plus b. It's actually y equals b plus mx, where b in this case is 5, and m, the slope, equals negative 0.5. So if we want to go to the graph and plot this inverse demand curve, which is also the demand relationship that we're really interested in graphing here, what we can do is we can find a y-intercept, a price intercept of 5, and draw the line so that it has a slope of negative 1/2. So that's going to look something like this. And let's make that a little thicker so that you can see it there. And we will label this as our demand curve. And to be complete with the labeling, you see that the intercept is indeed 5, or at least we want to conceptually highlight that fact. And if you really want to see how a good way to think about slope is, well, we go down by 0.5. For every 1 we go over. So that's a complete depiction of this linear demand curve. You can see, if you're comfortable with slope-intercept form, one way to get it into sort of an equation that's conducive to graphing is to solve your original demand curve. Highlight in our example here, our original demand curves right here. Solve that for price as a function of quantity. Once you solve for price as a function of quantity, then you've got it in slope-intercept form. And if you're more comfortable with that, that's much easier to graph. So hopefully this tutorial is helpful in understanding how to go from a regular demand curve, quantity as a function of price, and then furthermore going to an inverse demand curve, which is conducive for graphing, showing the difference and highlighting the fact that we use both inverse demand curves and demand curves in economics.